Yeah, welcome. I hope you're all slowly resurfacing from your after-lunch energy dip, now that you're all properly caffeinated again. I'm here to talk about practical code archaeology. And like all good things, this talk started out as a joke. There was a Twitter thread going on discussing talks that people would be willing to submit to NormConf, another machine learning focused conference that will be in 2 weeks. And someone posted as a joke this title, the title that I'm presenting today, figuring out what that notebook from 2 years ago did, practical code archaeology. And I thought, wow, this is a talk I would definitely watch or visit if I would be attending. But then the schedule was released for NormConf and no one had contributed this talk, and I felt really sad. So I decided, well, I'm just going to try and write it myself. And I think the reason that this talk title resonated with me so much is that I've seen code archaeology, or at least whatever I pictured for that term, I've encountered it in every part of my career so far. So now I'm wondering, who of you in this room already secretly feels a bit like a code archaeologist? Who is familiar with this feeling of digging around in old, frustrating code? Yeah, definitely. It's more than half of the room. So this was also my feeling. I'm really great that I'm today here with you because we share this feeling. So my career so far, I'm now a senior machine learning engineer at Florijn. Well, machine learning engineers and data scientists are digging around in legacy code all the time. Before that, I worked as a researcher at the University of Twente, and before that I worked as a computer security specialist at the government. And in all these three roles, there was definitely digging around in old legacy code. So from students, from professors that might have been retired even, tools that were created by colleagues in their spare time and that suddenly ended up in production, code from our interns from 1 or 2 or 3 years ago, which is ancient history at a machine learning startup, right? So wherever you are and whatever role you have when it relates to data or software, I think there is a code archaeology component to your work. So, code archaeology. What do I mean by that? Well, just dealing with old stuff. Skeletons in your company's closet, or maybe your side project that get abandoned. Dealing with anything ranging from notebooks to maybe Stack Overflow snippets that got copied over by one of your colleagues in the past, databases that no one dares to touch anymore, APIs that are or are not maintained, code in the broad sense of the word, right? Another term for code archaeology is software archaeology. So I guess it's all the same. It's really, really, really frustrating to do that digging around in old unmaintained or undocumented code. So why do we do this to ourselves? Sometimes we would just want to know, okay, I have this piece of code here. When did we last work on it? Who can I contact if I want to know how I can expand on this? Sometimes we get something from a really questionable source. So in my security time, that was malware, for example. If you unpack malware and want to see what it does, that's also digging around in code from which you don't know the origin. Or, well, I'm sure you can come up with examples from your own line of work as well. There is one advantage to that frustration and that pain of code archaeology, and that is that when you're digging and when you're going through all those frustrations, this teaches us how to be better software engineers. So that's the silver lining I can tell you about today. You will encounter things, maybe you did it yourself in the past, maybe it was your interns or your colleagues, former colleagues, that will make you go, oh God, I never want to see this again in my life. So it will teach you about maybe improving your software engineering skills a bit. Code archaeology is super broad, and I think that depending on the sector and your experience and your background, you might have different approaches to it. So I only have 30 minutes to talk about all the stuff that I like about code archaeology, but I have 3 main points that I would like to give to you. The first one is we're probably all technology-focused people, and we just love the next shiny, big thing in technology land, right? And I'm here to tell you that most of the code archaeology things that I've done were always solved way more easily by just talking to people, going out there, hunting down the people responsible, or just trying to work together instead of throwing more and more shiny tools at it. Secondly, we don't only love technology as technology-savvy people, we also love complexity. But complexity adds more confusion to the mix, so I am here to ask you, please always start with the simplest tool or simplest solution that you know. And the third point is, sometimes the really simple steps don't work, or talking doesn't get you anywhere. For example, the person responsible for the code has left. There's nothing you can do. You have to work with whatever skills and common sense and tenacity you have. At that moment in time, just try to use everything that you have and know, and use whatever detective skills you have. And to use them, we must first develop them. So take the time in your work schedule or in your study schedule or personal development time to get some detective skills under your belt, because it might not seem immediately relevant, but it will definitely save you time in the long run. Now, if you have no clue as to where you could start with developing some what I call detective skills, anything written by Julia Evans is a really good place to start. So this is an abstract of one of my favorite comics by Julia Evans, which is called How to Be a Wizard Programmer. The too long didn't read is just ask the good questions and dare to ask those questions, because it's perfectly fine not to know anything. The only thing you can do is take it one step towards a solution. If we're going to talk about code archaeology, of course, we have this group of people that have been working on dealing with old, dusty stuff for a few hundred years more than we have done as software engineers or data scientists or whatever you call yourself. And that's, of course, real-world archaeologists. And the thing that they do that I really like, and which I think we should learn from them, is that we should study the culture from which artifacts come. So in our case, the artifacts in question are pieces of code, for example, and the culture is the person or the group of people that has made this thing and that have left traces or information in that artifact that you're studying. So I would like to turn now to Indiana Jones. He might not be recognizable without his hat, but this is actually Indiana Jones, Harrison Ford. He tells his classroom at some point that 70% of archaeology is done in the library. And I would like to badly paraphrase this by saying that 70% of good code archaeology is done just by talking to people. So go out there and collect all the stories that you can find, for example, at your workplace. And I brought a few examples that I encountered in my career so far. So, for example, if you encounter a list of product names somewhere in a database in your company, and it turned out they're all really handily coded by alphabetical letters, and there's one missing, what do? You go to your CTO or CEO or most senior colleague, or maybe the person that worked there longest, and you say, what happened to B? Where is B? I need to know. It turned out that there was definitely a story behind this. So apparently the company where I encountered this used to have a product called B, and it was really popular, and it was really, really profitable, but it was really bad for the client. And once the company found out, they designed it like this, but by accident. Once the company found out, they immediately moved everyone over to the subsequent product, which was C, and they completely erased, or tried to erase, B from all production. But of course, if you start digging into legacy code at that company, you will find remnants of B. And at that moment, it's really handy to know what the story behind that is. Another example, imagine looking at the code that is run in production at a car dealership, and you find out that the most important class in all their models and all their production code is called bike. that's really illogical. So what's the story behind this? And again, you go to the person that works there longest and say, what's this bike thing I keep seeing everywhere? It's in every database query that we make, and it's in every dashboard that we have, but we sell cars. What's up with that? Please explain it to me. And it might turn out that this car dealership at some long ago moment in time started out selling bikes, but had to pivot for, business reasons. But at that point in time, all of their production code, all their inventory information, for example, already used this name, and it would be too expensive or time-consuming or not handy to rename everything that you have in production. And that's where this bike thing comes from. And then the last one, same goes for table names. You might have multiple tables in your data warehouse or data lake or whatever, all with slightly different but very similar sounding names. Now imagine your boss tells you to, just run an analysis on license data for me, please. I need it tomorrow. And you have these 5 different tables that you can just pull things out of, and they all kind of look the same. What do? Well, you'll have to ferret out what the differences are and where they are critically different. The company where I got this example from, they had multiple sources of data. So they had their internal data, they had data from 1 or 2 data suppliers, they had data from a government or oversight committee. And all these parties used the same word for slightly different things. So it turned out that these tables were not the same at all. This was just how the supplier gave them the data, and they never bothered to rename it. Now, I was asking my colleagues how they do code archaeology, and one of my colleagues said what I think is the best summary of how I like to approach code archaeology too, and that's like this. She said, well, I do git blame, git blame, git blame, and then I slack someone. And I think that's really the core of what I want to talk about. It's just that, when you're using git blame, it's not necessarily fun to read, right? You get this entire file annotated with who contributed what line and when. The fun thing is that, of course, we have other browsers for going through commits. So the thing that I like to use is Tig, which is just a regular commit browser. It's much more user-friendly, if you ask me. So you can use it on a repository. So, sorry, no live coding. And it will show you all the commits, and also merge commits denoted with an M. You can see the different branches and how they relate to each other. You can open up a commit and inspect it, but how I use it for code archaeology is you can instead call it on a specific file, and it will give you the entire history of that file with the names of whoever contributed and when. So this is much easier on the eyes than, the git log output that I know a lot of people use. Of course, you can also just install plugins in your IDE if that's your jam. That's fine too. I only started using an IDE 6 months ago, so don't know anything about that. There's also a cool thing that we can learn from archaeologists, I found out by accident. Archaeologists use stratigraphy, which is dating objects based on the layer of soil they were found in. So with this, something that is found in a high soil layer is younger than an object found in a lower soil layer, which is logical, right? Because history just adds layers of soil to the earth, and if you dig deeper and deeper, you will find older and older things. The fun thing is, I love this color chart. We can do something similar for our git blame output to make it more easily readable, it turns out. The default color settings for git blame color by age are not that useful, so I believe it does something like color everything that's newer than 12 weeks ago white, then everything that's younger than 1 year ago blue, and then everything that's older than that is all the same. However, I wrote this beautiful one-liner, which I will now explain. Basically, we add a rainbow. I'm a big fan of rainbows, that color codes every line of code by year. And of course, if you have a different use case, or you work in very short project cycles and you want to see one color per project, for example, you can also do that, because this is all customized. So in the first bit of the one-liner, we say, we're just going to change the configuration of this Git repository. Don't touch anything else on my system. So I recommend that if you're trying to Git config things outright. In the second part, we add a custom color scheme. And the third part is the custom color scheme. So we start at the one end of the rainbow, red, 6 years ago. And we end at magenta for 1 year ago, and the rest is just white. So white is recent. And then you can make a beautiful layer cake like this, which is very close to the stratigraphy illustration that I showed you earlier. This is just for fun, but you can immediately see that it's immediately easier on the eyes. You can definitely see the different blocks of code that correspond to different moments in time. So other neat command line tools. I'm a big fan of the Linux command line, so if I have a problem, I will always start with, well, tools like this. I would like to encourage you to pick whatever tool you like to use and read the man page. I'm pretty sure you will find a command line flag that you did not yet know about that might come in handy somewhere in the future, like the color by age git blame did for me. Of course, all the tips that I gave so far, they kind of apply only to code that is under version control, right? Because if it's not under version control, we can't git blame anyone. And as Python/data enthusiasts, I think a lot of us work with notebooks. Of course, you can put notebooks under version control, but since every cell execution will be embedded as metadata in that notebook, putting it in a repository is very tedious. I don't think most people do that. So what are our options if it's just, freestyle, no versioning code? I was talking earlier about that I would like to encourage people to just use the simplest approach they can take. And this is something that a lot of people then say they will do, right? Just run the code. See what happens. As a former computer security person, I would like to ask you, please, please, please don't. At least read it first. Just the other day, I was working with some game files. I've done some video games research in the past, and I love tinkering with those in my spare time. And I found a very neat script on GitHub that told me, well, I can unpack all the game files that you want. Those are often in proprietary formats by game publishers. Just run it, just point this thing at your Steam directory, and it will do magic things for you. Turns out it overwrote game files in the Steam directory. It didn't ask the user. I mean, the script looked fine. It had documentation, it had very usable terminal arguments that you can use. It looked like a very polished piece of software. But if you opened it up and read it, it turned out that it was just overwriting all your save files and destroying everything that was in the game directory. So that's very painful. Reading code is, of course, I was afraid that was my 30-minute timer, but it's not, so no problem, no problem. Great. Reading code is a skill, right, that we all need to develop. And some people really don't like it, especially if it gets to more than 100 lines of code, for example. But the cool thing is, one, with practice, it does get better. And I think that the people of you who have contributed to open source code, for example, will know that once you get more and more exposure to other people's code, it improves, and it improves fast. So I would say it's worth the time investment. And also what I really like is that the stuff we learned in high school about reading non-fiction texts is applicable to code. You just have to kind of transform that knowledge and make it applicable to code. But it is the same. So in high school they teach you, try to answer the basic questions first. Who, what, when, and why. And especially for the who, I like to keep this mental profile of all the people that I know at a company and try to pattern match their coding style to the code that you see. I think you all have a colleague that codes in a specific way, and that if you see code written by this person, you go, "It was you!" Well, you can use that knowledge if you're digging down in company code, right? The other thing is that they teach you in high school that if you're reading a non-fiction text and you have to answer questions about it, you have to focus on the most important parts of the text. So for non-fiction, that's things like headings, you look at images or graphs, you look at captions, maybe look at keywords or blurbs that jump out at you from the text. And with code, it's just the same, right? So there's a priority list you can go through and start with the most important points. So I like to focus on the input and output, especially since the example that I told you about happened. And things like dependencies, code structure, class names, logging. So you can use this slide as a checklist, I would say, to get to the most important points of the code first and to really understand what it does and answer the questions that I just showed you. If you have to read a large piece of code, another thing that I can really recommend is pair on it. So I didn't really know much about pair programming before I went to work at Florijn, but there's a really good guide by Tuple, which is a company that has written a guide about pair programming, and I'm a convert. I always used to think that pair programming is doing the work of one person with two people, so it's less efficient and costs double the time. No. Give it a spin. It is actually much faster, and it's also more fun if you're trying to figure out what a piece of code does and you can work together like a detective duo. It's much more efficient and it's way nicer. When all else fails or the reading the code does not give you the information that you're looking for, or you really need to dive in deeper, of course you can run the code. You can add comments, for example, to make it all a bit more clear for yourself what the code is doing. You can add some logging. You can try to come up with some mock-up inputs so it doesn't destroy important files. And I would recommend that you try to keep your development environment as clean and safe as possible. So use not just virtual environments and PyEnv just to get it working. Consider using Docker containers or a virtual machine, or run it on an air-gapped computer, for example, depending on your line of work and how dangerous the code in question is. Just make sure it doesn't mess up your production. Now, to wrap things up, I promised in the abstract of this talk to answer the question, do I need to bring my hat for code archaeology? And code archaeology is an activity that we pursue indoors, so I would say no. Instead, bring some comfy clothing, your favorite caffeinated beverage of choice, and a toolkit. The simpler the tools, the better. And a good dose of grit, tenacity, and quite some patience, because I think that's what you need most for code archaeology. Thank you. I'll be happy to take any questions.
Thanks, Judith, for this presentation.
Oh, sorry.
No worries. I wanted to say thank you. And thank you for digging up these useful tools. I find them useful, and you promised memes. We got some memes.
Yes.
I like them. So
I learned from the best.
questions. It was you first, right?
So thanks for the talk. I felt very identified with your thoughts. One of the things you said is that the more code of others and archaeology you do, the more you can learn to write things properly. I fully agree. So do you now write more comments or write more explicit code?
I would say, but that's also thanks to my colleagues, because I'm an ex-academic, and the code I used to write was horrible, and now it's slightly less horrible. It's mostly because of the mentorship of my colleagues. I think the thing that changed most is my code structure. So writing in the more object-oriented way, so that you can, from just reading it, immediately see how it's supposed to be used, and in what context. Does that answer your question?
Oh, yes.
Good.
Any other questions?
Just to continue on that, do you also write more unit tests now?
Yeah, well, you know, I'm working in an industry company now, so yeah, we test the lot because it's production and it shouldn't break. Academics generally don't write tests. I'm sorry.
Smart.
If you want a very nice place to start, by the way, of learning more Linux command line tools, Julia Evans also has a list of the command line tools that she uses most of the time, which is, I think there's about 30 of them. That's a really cool place to start. So depending on what you do most often, you can pick one or two. So for the network-oriented people, netstat or TCP dump, for example. For the people that work a lot with data or texts, I would say find and grep. Grep is really my favorite in that sense. But I used to be in NLP, so anything with regular expressions is my jam.
Yeah, since there are no other questions, I will just ask, do you have any ideas about data archaeology? If you have a bunch of Excel files, PDFs?
Oh yeah, there's a lot to be said about that. Maybe I should give a follow-up talk next year about that. So I used to work in digital forensics. So that means that whenever a computer crime or a computer security incident has happened, you go in and you try to extract as much information from whatever happened as possible. And it would amaze you how much metadata is hidden in files and in operating systems that you can forcefully pull out of there if you know what tools to use and what keywords to Google. So, for example, notebooks, they save all this metadata about the cells that have been executed and in which order and maybe even by whom. There is so much information. You can extract like a complete timeline from a notebook if you know how to. I believe there's open source packages for that, so pretty cool.
Any more?
So a comment and a question.
Yeah.
The comment first is what you said about notebooks being very hard to put in Git. The way we sort of solve that is that we have CI clear the notebooks before they're checked in, and then save the HTML, which contains all the history, separately. So then if you have your notebooks in Git, you can actually see useful diffs of them in merge requests and stuff.
That sounds really useful.
Yeah, so that's a nice tip.
Nice.
Yeah, we have a snippet somewhere for that if people need it. And then my question is, I think as programmers, we're always quite afraid to delete things. Like we think, we may need this later or something. And I know earlier this week, Tom and I were working, we had to, work on some old notebook, but there were actually two notebooks that looked like the first half was the same and then the second half was different. And it was like, okay, obviously one of these was first, but they were checked in at the same time.
Yeah.
And they were both clear, so we didn't know when they were executed. So like, which one is the one I need? So maybe, do you have thoughts on like best practices for when you fork something and it's like, this is the one I want, but I don't want to delete this because maybe someone will need this later, and then a year later you come back and you're like, wait, which one of these is actually the thing?
Yeah, I think in my company I kind of see two styles working in that sense. So as a former academic and maybe code archaeologist, I tend to not delete anything ever, which sometimes is a problem. My tech lead, on the other hand, has started complimenting people for deleting as much lines of code as possible. So there's the information hoarders versus the let's iterate fast and change things. I would, in this case, make a third notebook probably and try to... It depends on what you want to do, right? If you're just investigating or whether you want to rerun it again. If you're just investigating, you can use the open source package for extracting metadata that I mentioned earlier, and maybe find out which notebook was executed latest, because it will tell you something about the timeline of both the notebooks, and maybe you can work from there. If you just want to run it, I don't know, read the code and try to make like a third fork version of both the notebooks and keep the best parts. That really depends on your use case.
But I meant more like at the time of doing that, you know, maybe it would have been good to label it or something. Or like, is there
better
stuff to think
naming,
about?
add more documentation. That's the pain I was talking about. Once you've gone through a project like this, I will shut up now. Once you've gone through a project like this, next time you will think, oh yeah, we had those 2 notebooks. This was made by this and this person on this and this date for this and this purpose, and you never have that problem again. I hope.
Question?
Okay.
Last question, or not a question, is why not just delete it because it's in Git anyway?
Yeah, that's also a possibility. It really depends on how essential it is.
We worked on it for a year and now it's gone. We don't have to look at it again. It's a failed attempt. So.
I'm not sure that qualifies as a question, though. This is a good joke. Do you wanna?
Yeah, well, I was wondering. What if someone changes the Git history?
Ooh, yeah, yeah. Force that depends on whether your tech team allows force pushing.
But what if it happened? How do you do archaeology?
Well, then you can always do the non-version control code techniques, right?
Yeah.
You just have to use more of your detective skills.
One final applause.